Okay guys, today we're going to learn a new integration technique which is called the U-substitution. So basically the idea of the U-substitution is to replace an integral that you can't integrate directly to an integral that is equivalent but you can integrate directly. So yeah, let's try a problem. So if we have the integral of ln of x over x dx, okay, and we wanted to figure out how can we rewrite this thing, because right, you can't, there's no direct there's no direct way to integrate this. So basically what we do with U substitution, we basically rewrite the integral directly and convert it in terms of the new variable u. So we write a new function. We say that u is equal to ln of x. So now we want to take the derivative of this. So this would be du, and we know that the ln of x differentiates to 1 over x. So we can rewrite this integral completely, because we know that we have all the pieces here. We have u here, which is our ln of x, and we have du here, which is 1 over x dx. So this integral is equivalent to the integral of u dx, du. And right, how do we integrate this, right? We know that this is to the first power, so how do we integrate this? Well, what we do is we know that this will integrate to u squared divided by 2. And why do we know that? Because we add 1 to the exponent and then divide by the new exponent. But we're not done yet. We're technically not there yet. We still have it in terms of u. Now we want to make the substitution back in that u was ln of x. So this integral, well, technically this is, the integral is not here now, because, right, that was my mistake. We integrated it, so this is our function. This is our f of x. Well, this is technically our f of u, but we're going to convert it back to our f of x. So, and then we made the substitution, so ln of x squared over 2. So this integral right here, ln of x over x, is equivalent to ln of x over ln of x squared, ln of x squared over 2. Now I'm sure you're like, oh, prove this to me. How is this the derivative? How is this the original function? Well, if I am correct, and I am pretty sure I am, that the derivative of this thing will actually be our ln of x over x. So let's check that out. So if I'll just rewrite the whole thing. Hold on. If I do d dx of ln of x squared all over 2, what does this get me? Okay, so we basically have to follow chain rule here. So we know that this is equal to 2 ln of x, but what do we still have to do? We still have to take the derivative of the inside, which is 1 over x. So we have 1 over 2x. So, and then what happens? These cancel, and this 1 multiplier, that doesn't affect anything. So look at that. We got the integrand. We just tried the integrate. So we did successfully integrate it. So basically with U substitutions, and I'm sure you're like, why did I know how, u was ln of x and du was 1 over x? Well, I saw that if I made u ln of x, that the derivative of that was 1 over x, so that I could simply substitute. Now, in theory, you didn't really have to do that. You could do probably an integration by parts thing, but I haven't taught you that yet. So to be honest with you, in some methods you want to use substitution, but in other methods you want to use integration by parts. And in this situation, like even in a U substitution, if you chose, I know you don't know about it yet, but if you chose integration by parts, it would still work out to be the same thing. So yeah, basically the U substitution is used to write complex integrals that we can't integrate directly into simpler integrals we know how to evaluate. So that's basically the video for today, and I will catch you later.